So arithmetic sequences is a very common class of sequences in which each consecutive term in the sequence is a fixed value larger than it previous the previous value of the sequence. Alright, so some features of an arithmetic sequence is the common difference, in which it is that fixed number where the consecutive sequence is increased by decreased by from the previous value, and the initial value is the very first term of the sequence, starting the sequence off. Alright? So there are two ways in which we can represent an arithmetic sequence. I will write this in variable form and we'll add it on. So we'll start with a sub n. I'll talk about this later on. Is equal to a sub 1 plus d n times n minus 1. That's the explicit, and the implicit will be a sub n is equal to a sub n minus 1 plus d. N minus 1, my thing is very slow, I have no idea why, plus d. Alright, so let's move to our very first problem. Alright, we're giving the sequence. Alright, we are given the sequence of -5, -7, -9, -11. Alright, so let's find the value in which each of the sequence is increasing by. Going from -5 to -7, we get -2. -7 to -9, we also get -2. -9 to -11, also get -2 again. So in this problem, our common difference is -2, and the common difference will be represented by d. -2. d is equal to -2. Alright? And then, so our initial value is the very first value starting the sequence off, which in this case will be -5. So our a sub 1, which means the initial value will be -5. So right now we'll put these number. I have no idea why this is so slow. It is very annoying. But I'm so sorry you gotta deal with this. So right now we'll put the initial value and the common difference into the solution form of the explicit and the implicit and the recursive way of representing it. Let's go down to the very bottom. Okay. Not too far. Alright, we're reaching the bottom. Alright, let's start. So let's bring the value down. A sub 1 is equal to -5, and d is equal to -2. Alright, what do we do? We'll start with a sub n, then n equal 1, going from the sequence of a sub n going from n equal 1 to infinity. Alright? With a sub n, I'm writing right now how to represent it in the explicit way. With a sub n being equal to the initial value, which in this case is 5. My bad, -5. Alright. Plus the common difference, which is in this case is -2, multiplied by the index, which is n minus 1. Index minus 1. So the index basically represents the the nth amount of term in the sequence. So let's say you want to find, well, let's do it right now. Let's say you want to find a sub 14. Well, instead of looking at this sequence and start counting. So a sub 1 -7. That's the second. The second is the second sequence. Keep counting -2 up instead of having. Oh, okay. You don't see this. I'm sorry. All right. So instead of having to count from one value to the next, like from -5 to -7, your -7 is -2. It's basically the second sequence. Well, instead you can just easily just use the use the explicit way of representing it and just plug it in. So your number is 14. So you're trying to find the 14th term in the sequence. What do you do? A sub 14 is equal to -5, our initial value, plus -2, which is our common difference, the integral 14 minus 1. So what do we get? We'll get -5 minus 28. Oh wait, I'm sorry. We'll get -5 minus 2 times 13. So what do we get? We get -5 minus 26. These two values will be added together, so our a sub 14. So 5 minus 26. So these values will be added together. So our a sub 14 will be equal to -31. See, that's how you put it into action. Alright, so lastly, how do you represent it in the recursive way? We will once again write the sequence of a sub n, a index of n, ranging from the value of in the index starting with index equal 1 all the way till infinity, with a different way of with a sub n is equal to a sub n minus 1 plus d, which is your common difference. So as what I wrote earlier in the thing, now let's just plug everything in. We will still keep the n minus 1 because that's our index of whatever we want to plug in next. Leave it right there, alright? So we'll get a sub n is equal to a sub n minus 1 plus -2. And this, okay, let's just erase this, plus -2. This is how you will represent it the recursive way. So we went over recursive and explicit way of representing arithmetic sequences and what are its feature of the common difference and the initial value. And that's it for me explaining this lesson. Thank you for listening.